Hi, everybody. My name is Ian Miller, and I'm a coastal hazards specialist for Washington Sea Grant. My snapshot today will focus on a small project I've been working on, partnered with colleagues from the U.S. Geological Survey, that focuses on methods for efficiently measuring bluff erosion, applying what are called structure from motion algorithms to photos collected quite readily with a simple off-the-shelf camera, and in a way that could be easily applied within the context of a community science program. Before we dive in though, and because this is a remote presentation, I just wanted to throw up a picture of who is talking to you. I live and work out of Port Angeles, Washington, and my role in this project was to collect coastal bluff photos along a stretch of shoreline just to the west of Port Angeles, adjacent to the Elwha River Delta. The bluffs here are, like many of the bluffs within the Salish Sea, of glacial origin and generally erode at pretty fast rates, on the order of a half of a foot to up to perhaps a foot a year on average. And our problem statement guiding this project is one that won't come as a surprise to many of you. Eroding coastal bluffs are a common shore form in the Salish Sea that also support thousands of residences or other types of infrastructure. The interaction of the erosion and that development leads sometimes to bad outcomes and makes insights about how and when these bluffs erode very useful. But erosion data for coastal bluffs are surprisingly sparse. The tiny dots on this map, for example, are long-term bluff erosion rates available in Puget Sound. And there are large stretches of shoreline between these dots where no rates exist. Additionally, these are long-term rates, whereas bluffs erode in fits and starts, responding to things we think like large waves and heavy rainfall. Having higher frequency measurements of bluffs would enable new insights about how and why bluffs erode, how that erosion might be managed, and how patterns of erosion may change in the future. One option for addressing this data gap is an old technology called photogrammetry, which uses geometry to create a three-dimensional model of the land surface from two-dimensional images. The power of photogrammetry has been radically enhanced by computers, which can rapidly do the variety of calculations required, and structure from motion algorithms can now ingest digital two-dimensional images of the landscape and generate high quality and very accurate elevation models. And investigators like my colleague and project partner John Warwick at the U.S. Geological Survey have shown that you can extract very useful information about rates and patterns of coastal bluff erosion from publicly available oblique imagery. For example, like oblique aerial images collected as part of the California Coastal Records Project. The point of this project was to take things a step further and ask if we could generate high-quality models of the bluff surface from photos collected by relatively untrained personnel like myself with simple off-the-shelf cameras. This, for example, is the rather simple, inexpensive, and notably threadbare camera that I used for the collection of some of the imagery we used in this project. The coastal bluff imagery analyzed in this project was, again, quite simply collected during walks, or in some cases from small boats, along the beach, snapping a photo of the bluff face every 10 to 15 paces, such that there is at least 50% overlap between adjacent images. The camera's GPS information was included with each photo, and for some, but not all of the data sets, an RTK DGPS unit was used to assign a high accuracy location of the camera to each of the images. And the short answer to our question is that this approach works. Here, for example, are two coastal bluff surfaces. These are models generated from these photos, one from November 2016 and the next from January 2017. And during the intervening 3 months between these data sets, there were two small but visible failures on the bluff face that I've outlined here in red. And what we found is that we can readily detect those failures in the digital surface models derived from these images, suggesting strongly that this is a viable technique for collecting more bluff monitoring data more cheaply and more efficiently, and by leveraging community scientists. So by way of conclusion, I would say that this approach holds promise for efficiently mapping bluff erosion across larger scales than we've done before in the Salish Sea. We've got a paper forthcoming that describes the project in more detail and assesses optimal processing techniques for the imagery. From here, we hope to do some additional work to better pin down quantitative uncertainties, essentially how good are the resulting models. But we may not be too long before starting to think about standing up a community science project to encourage the collection of photos from new locations in the Salish Sea. With that, thank you.